Hi guys, good morning. All of you, can you see my screen?
This conference will now be recorded.
All of you, can you see my screen? Please confirm. Yes, right. In the last session, we discussed about custom sequence creation and using that in our entity to generate the value for primary key column. Now, today's topic, working with custom generators. Working with custom generator. All right. So we discussed what is generator, right? Generators are used to generate value for primary key column. Generators are used to generate value for primary key column, right? So there are several predefined generators are available. There are several predefined generators are available to generate value for primary key column. To generate value for primary key column. Next. Every generator has its own algorithm to generate the value, right? But sometimes we need to go for custom generator according to our requirement. Sometimes according to client requirement, sometimes we need to go for custom generator. Use case employee IDs, EMP IDs I want in this format. Suppose TCS is there, TCS 01, TCS 1, TCS 2, TCS 3, etc. I want numbers like this. Now suppose online orders. Whenever a order placed in the online, I want to generate online order ID like this. Online order ID is OD1, OD2, OD3, etc. Like this, right? Now, so I want to generate the value for my primary key column in this way. So company name I want to use for the employee ID. OD should represent as a order for the order ID that we are placing. So to meet this kind of requirement, we need to go for custom generator because Hibernate doesn't know what is TCS. Hibernate doesn't know what is this OD, right? The generator will generate the value, a numeric value, a alphanumeric value. But in this way, they can't do that. Predefined generators cannot generate the value in the format which you are looking for because it is your project requirement. It is not the universal requirement. It is not the universal requirement. It is your requirement. You want in the ID with the TCS as a prefix, but some other company, Oracle, will have ORCL as a prefix. IBM will have IBM as a prefix. So everybody having their own requirement. But for this requirement, we don't have any predefined generators in the ORM frameworks like Hibernate. But what that ORM framework Hibernate told was, I am giving you few generators. Those generators will work according to my algorithm. They will generate the value according to my approach. But if you have a custom requirement, then my predefined generators are not going to support for you. Then you have to develop your own generator to generate the value in this format. You have to develop your own generator to generate the value in this format. That's where custom generators comes into picture, right? Now, how to develop a custom generator? So to develop a custom generator, we need to implement one interface called identifier generator. To generate, to work with, to create custom generator, we should implement we should implement identifier generator interface. We should implement identifier generator interface. In that interface we have generate method. We should write logic in that method. We should write logic in that method. We should write logic in that method to generate pk column value, according to our requirement. So now I hope you are clear with the use case when we need to go for custom generators. So according to your client requirement and according to your project requirement, if you want to generate a value in some customized format, then predefined generators are not going to support for that. There you need to create your own generator. So that generator which you are creating is called as a custom generator. In order to work with custom generators, we should implement identifier generator interface. In that interface, we have a generate method. We should write logic in that method to generate the pk column value according to our requirement. Now, first let us understand how we can generate a value like this. Now, for this, first I am trying to understand what approach I need to use to generate a value like that. I need to understand what approach I need to use to generate a value like that. Now, if we see that IDs are looking like this: OD1, OD2, OD3, OD4, OD5, and so on. So in this format, I want to generate those values like this, dot dot dot, OD100 also. So in this format, the IDs should be generated for primary key column value in my application. I want to generate the value like this for primary key column in my application. This is the requirement. Order ID is a primary key which should contain the value like this. Order ID is a primary key, it should contain the value like this. Are you able to follow this? Now it is alphanumeric characters, alphabets are there and numbers also available, which is alphanumeric characters. So the first thing that you need to understand, column data type should be varchar, because it is not only numeric. If it is only numeric, then we can take number as a data type. Here it is alphanumeric, so column data type should be varchar. So to store value in this format, if we want to store value in this format, our pk column type should be varchar. All of you clear with this point? If we want to store value in this format, our pk column type should be varchar. If we want to store value in this format, our pk column type should be varchar. Fine. Now, so if we observe the values, we need to come to one conclusion. It is having alphanumeric characters, right? So I can divide these IDs into two parts. Whatever the IDs that are there for the orders, right? Based on analysis on the data, we can divide that into two parts. One is called prefix, another one is called suffix. You can divide this ID into two parts. One is called prefix, another one is called suffix, right? The order IDs can be divided into two parts. Order ID can be divided into two parts. One is prefix, another one is a suffix. So one is prefix, which is OD, right? Next one is suffix, it is number, start with 1, increment by 1. Prefix is OD, suffix is a number, which is starting with 1 and incrementing by 1. Now if you can break this logic, then it is very easy to work with this custom generator. It is starting with 1 and it is incrementing by 1 only. Starting with 1 and increment by 1 only. Are you guys able to understand? So if I have taken order IDs like this, so to store the value in this format, our primary key column type should be varchar, and the order ID can be divided into two parts. One is called prefix, which is OD. Another one is called suffix, which is number start with 1 and increment by 1. It is starting with 1 and it is incrementing by 1. All of you clear with this one? All of you clear with this one? Now, prefix as a fixed value, prefix is OD, it is fixed value. Prefix is OD, it is fixed value. Suffix is a number starting with 1 and incrementing by 1. Starting with 1 and incrementing by 1. Now, here, as it is fixed, we can read from a YML file, or we can keep it as a constant also. We can read it as a YML, or we can keep it as a constant also. But what about suffix? Any idea? How can I generate this number starting from 1, incrementing by 1? Anybody have any idea on that? Does anybody has any idea on that? Start with 1 and increment by 1. Come on, how can I generate that number? OD's problem is solved. OD is a fixed value. I can take a constant for that. But what about the suffix? Suffix is a number. The number starting from 1 and incrementing by 1. Then how can I do that? How can I do that number? How can I work with that number part? Prefix part is cleared. Then what about suffix part? Yes, I will use a sequence to read the value like that. I will use a sequence to read the value like that. Now, for suffix, as prefix is fixed, we can create a constant. As prefix is fixed, we can create a constant value for that, constant for that. As prefix is fixed, we can create a constant for that. For suffix value, we can create a sequence. For suffix value, we can create a sequence. I hope you people are able to understand this. Come on, read these 4 points. Right. Next. Now, as we are able to understand the algorithm that we need to use for the custom generator, now let us start working with the custom generator. I want to create one orders table. In the orders table, I want to generate order ID as OD1, OD2, OD3 like that. For generating that value, I will use a custom generator. For that custom generator, I'm going to implement one interface called identifier generator, and I will override generate method. In that method, I will write the logic which will return prefix plus suffix. Prefix is OD, suffix is a number which we are reading from the sequence available in the database. Got it? Now, steps to work with custom generator. Procedure to develop, procedure to use, steps to develop JPE application with custom generator. So what are the steps that we need to follow in order to develop custom generator in our application? Right. First one, create boot Spring Starter project with below dependencies. Create Spring Starter project with below dependencies. So what are the dependencies? Spring Boot Starter data JPA, Spring Boot Starter data JPA, Oracle driver, Lombok, which is project Lombok. Create data starter JPA, Oracle driver, project Lombok. Fine. Next, create entity class using annotations. Create entity class using annotations. Right. Next one, third step. Create sequence in DB. Create sequence in DB for suffix value generation. Create sequence in DB for suffix value generation. Then next step. Create sequence for in DB for suffix value generation. Next one. Create custom generator class. Create a custom generator class by implementing identifier generator interface. Create custom generator class by implementing identifier generator interface. Then configure custom generator in entity. Configure custom generator in entity. Like we are using @ID, right? Similarly, whenever we have a custom generator, that we need to map that to the variable which is binded to primary key column. Configure custom generator to entity variable. Configure custom generator in entity. Then create repository interface. Create repository interface by extending data JPA repository interfaces. Right, just go through these steps once. All of you read these steps. All of you clear with these points? Please confirm. Then we'll convert this into executable program. Please confirm, guys. Right. No. Let me create one new project. File new Spring Starter project. I will go with data GPA custom generator. Lombok, Oracle driver, data GPA. Three dependencies I am selecting. Next, finish. We need to configure data source properties. So I'm taking those things from existing project file. Data source properties and ORM properties also we are taking. In our application, by default, properties file is created. We can convert that into YML also. Right click on that properties file, convert .properties to .yml. After converted, I will just paste these data source properties. Yeah. No. Open this project YML. Yeah. So here I configured data source properties and I enabled auto DDL and I configured ORM properties also for that. Fine, good. Next step. Our project setup is ready. Project is ready. Dependencies are ready. Configuration is also ready. Now what is the next step? Create an entity class using annotations. We need to create our entity class in the project. That class should represent the structure of the database table. That class should represent the structure of the database table. Now go to package, new class, new class. Right. This I am keeping inside a package called entity package. Entity package. Now here I'm taking this one as order details. Order details entity. Order details is the class name I'm taking. Let me take some variables. Order ID. ID now I need to take as an integer, I need to take as a string. Order ID I need to take as an integer or I need to take as a string. See the structure of the ID that I will need OD1, OD2, OD3. So I cannot go for integer, so I have to take it as a string only. Private string order ID, private string order by private string order by, private date ordered date, placed date, order placed, that is a date type, so I'm taking date as a data type for that. Private date util date order placed, order placed date, order id and who ordered, that is order by, and when it is ordered, that is order placed date. Fine. Represent this as a entity class. For that we are using @entity annotation. Map it to a table @table annotation. Name is equal to order details. Name is equal to order details. Now represent primary key column. So to represent a variable mapping with primary key column, we use annotation called @id. We will use the annotation called @id for that. And the remaining things, non-primary key columns, can be mapped by using column annotation. If we don't write the column, still it will take variable name as a column name. If you don't write the column, still it is going to take the variable name as a column name. It is going to take the variable name as a column name. Fine. So we can specify what is the name exactly we want in the table by using @column. Name is equal to order underscore id. Order underscore id. Here order by @column. Name is equal to order by. Name is equal to order by. Next one, order placed date. For this I will use @column. Name is equal to order placed date. Name is equal to order placed date. Like this I am taking three variables. One variable is map representing as a primary key column variable. For that I gave @id annotation. Right. Now next, @data lombok we are using, so I'm specifying annotation called @data. Fine. So with this we are good with entity class, but still generator is not configured. For configuring the generator, we need to create a generator class. We need to create a generator class. That generator should represent the value in this format: OD1, OD2, OD3. So here if you really observe the data, we can understand OD is repeating and 1, 2, 3, 4 are incrementing. OD is a fixed value, 1, 2, 3, 4 are incrementing, right? So I will divide this ID into two parts. One is a prefix, another one as a suffix. So prefix is OD, fixed value I will keep as a constant. Suffix is a number which is incrementing. It is starting from 1, incrementing by 1. So I thought of using sequence for that. I thought of creating a sequence for that. Now in the identifier, in the custom generator, we need to read the value from the sequence and we need to add that to the prefix and we need to return prefix plus suffix. When return prefix plus suffix, that is going to be our custom generator value which is used for primary key column in the table. All of you clear with this one? Now first let me create a sequence in the DB. So I'm using SQL developer here to communicate with the database server. This SQL developer is a client software. One second guys, it is loading. Yep, it is good. I'm checking the existing sequences in this database schema. Order ID sequence already available. Let me drop that. I'm deleting the sequence. Yeah, sequence got dropped successfully. Now let us create the sequence once again. Create sequence. Order ID sequence. Start with 1. Increment by 1. Start with 1 and increment by 1. Commit this. Yeah, commit completed. So with this sequence is ready. Now we need to create our custom generator class as per our step. Sequence in the DB, we created that. Then create a custom generator class by implementing identifier generator interface. Right, now observe carefully, this is the important code that we are going to write. I'm giving the class name as order ID generator. Click on finish. Yeah. It has to implement one interface. Identifier generator, which is available in an interface called org.hibernate.id package. Now, in this one abstract method that is called generate, we need to override this method. Generate is one abstract method, we need to override that method, which is returning serializable object. The serializable object represents our primary key value. What is the value that you want to return as a primary key? For the primary key column that is representing by serializable object, this method is the one which is going to generate that primary key and will return the primary key to insert into the table. Now here, what is the logic that we need to write as part of this class? Look at our paint file. What is the logic I need to write? Can you guess now? 70% of the story is already revealed. What is the logic I need to write? What is the logic that I need to write inside my identifier generator implementation class? I need to take the prefix, I need to take the suffix, and I need to append, I need to return. That is the logic that I need to write. Try, catch. Try, catch. Right. First I'm going to take here string prefix is equal to OD. That's it. It is a fixed value. It is a fixed value. Now here I'm going to take string suffix. Currently it is empty. It is empty. Finally I should be able to return prefix plus a suffix. Finally, I should be able to return prefix plus a suffix. I should be able to return prefix plus suffix. Right. Now, prefix value already we have. From where I can get the suffix value? Come on guys, you have to be active. From where I can get the suffix value? From where I can get the suffix value? From the sequence. Sequence already created in the database. Now I need to read the sequence value by using Java program. I need to read the sequence value by using Java program. So to read the sequence value from the database, I should connect with the database. To read the sequence value from the database, first I should connect to the database. Right. In order to connect to the database, I need a DB connection. That connection I am going to get by using first parameter of the generate method. I am going to get that connection by using first parameter of the generate method. So which is giving me connection object. Which is giving me connection object. Look at the first parameter of that method. This method, generate method, is taking first parameter as a session. That session object I am using to get the connection object. Once connection is there, can I create a statement? Con.create statement. Yes, which is going to return statement object. Which is going to return statement object. If you have statement, then execute the statement. Statement dot execute query. Statement dot execute query. It is taking the query as a parameter. It is taking the query as a parameter. Now let me prepare a query to read the next value from the sequence. Order id underscore sequence dot next val from dual. Select sequence dot next val from dual. That is the query that I need to execute by using this statement object. By using this statement object. Now, what is the return value of this statement execute query method? What is the return type? It is going to be a result set. It is going to be a result set. You can call it as a RS. Statement.execute query of SQL, which is going to return result set object. Which is going to return result set object. Fine. Now, if rs.next Result set will point to the before first row. Cursor, I am moving the cursor to the next position if the record is really available. If rs.next, then I will go and get it. rs.getInt of 1, that is the index. rs.getInt of 1, that is index. Now, which is sequence value, which is my sequence value. Now what I will do is suffix is equal to string dot value of sequence value. So I'm converting integer to string. I'm converting integer to string by using value of method. Integer to string by using value of method. So the integer value converted to string value, that became suffix. Already I have a prefix. The prefix I am appending to suffix. Now e dot close. E dot print stack trace. E dot print stack trace. Now this is the logic that I am writing to generate the primary key according to client requirement. Just look at this logic. Nothing is difficult here. Simply step by step we are able to build. Just go through these lines of code once. Anybody not able to understand this piece of code? It is using the existing connection. It is using existing. We are not beginning any new connection. Session.connection, that will give the existing connection. We should not close it also. If we close the connection, operation will not happen. We should not close the connection. This connection we are using to read the sequence value. With the same connection, it is going to insert the record into the database. So that's why we should not close the connection here. Got it? rs.getInt method, it is used to get the value from the result set. Whenever the JDBC query whenever the query got executed by using statement in the JDBC, it will return the result set object. From the result set to get the data, I am using rs.getInt. It is column index. Value of method is used to convert given value to the string format. My suffix is a string data type. Actually sequence value is an integer. I want to convert that into string. For that I am using value of method. Converting integer type data to the string type data. To convert string type data to the integer, we will use integer and parseInt. But here reverse operation, integer to string. All of you clear with this? Still any questions on this class? No sir, here we can't use this ORM, we need to read the sequence data, right? We can't use the ORM. Just one query we are executing. We can't use the ORM here. We have to go with this JDBC. Fine. Next step. Let us configure this custom generator in entity. Configure a custom generator in our entity class. Observe carefully. This is our entity. This is our entity which is having three variables. Those are mapped to DB columns, right? First one is adder ID representing as ID. So that means it is mapped to DB column, primary key column, table primary key column. Order by order date, place date, these are non-primary key columns. Now, custom generator we need to configure for primary key columns, right? We need to configure for primary key columns. In order to configure that, we use one annotation called at generic generator. At the rate generic generator. For that we will specify name. We'll specify name, generic generator name is equal to order ID generator, comma, strategy is equal to, comma, strategy is equal to, one second, at generated value, I will directly use strategy is equal to com dot strategy dot generators dot generated value strategy. It is not taking. Second. I'm giving generated value is equal to generator order ID generator, which is order ID gen, which is the alias name that I gave in the above annotation, right? So this is the name of the generic generator which I am configuring as generated value, and the strategy it is I'm saying go and execute my order ID generator class to generate the value for primary key column. Right. Look at the entity configuration. All good. Now let us create our entity class. Sorry, repository interface. Hello. Good morning, sir. చేస్తాను సార్, నాకు నేను వస్తాను బ్యాంక్ దగ్గరికి. ఓకే. 5 lakhs ఉన్నాయి కదా, 5 lakhs ఉన్నాయి కదా ఆల్రెడీ. ఓకే. నేను 5 lakhs ఇప్పుడు పడ్డ తర్వాత నాకు అది డీటెయిల్స్, నాకు ఏటీఎం కార్డు, చెక్ బుక్ అన్ని వచ్చిన తర్వాత నేను మిగతా అమౌంట్ ట్రాన్స్ఫర్ చేసుకుంటాను. ప్రజెంట్ మినిమం 5 lakhs కదా, 5 lakhs ఆల్రెడీ పెట్టాను కదా, మిగతా డీటెయిల్స్ నాకు ఇచ్చిన తర్వాత మిగతా ట్రాన్స్ఫర్ చేసుకుంటాను. ఓకే. నాకు ఎప్పుడు ఇస్తుంది కిట్ అది? 10 days. ఆన్లైన్ బ్యాంకింగ్ ఎప్పుడు? మరి ఎట్లా ట్రాన్స్ఫర్ చేయాలి నేను ఇప్పుడు? ఒకరు కుదిరితే వస్తాను, లేదంటే నాకు కిట్ వచ్చినా చేసుకుంటాను. మీరు ఇది ప్రాసెస్ చేసేయండి. ఓకే. I need to create a repository. Let me rename order details repository. You should create it as an interface. Interface. Now it is going to extends from JPA repository, which is taking order details entity and which is giving serializable type, which is giving serializable type. Right, that's it. So like this I created data JPA repository by extending the properties from JPA repository, which is a predefined repository. So I hope no questions with this repository also. Next, let us test it by getting the bean object. Run method, it is returning context object. Returning context object. Now context dot close, context dot close. Fine. Get the bean context dot get bean of order details repository dot close. Now we are getting the repository bean. That means runtime will get the implementation for that bean as a proxy. To insert the record, we have a save method. To insert the record, we are having a save method. For save method, I need to pass entity as a parameter. Order details entity. Entity is equal to new order details entity. New order details entity. Set the data. Entity dot set order by some Miller entity dot set ordered date, order placed date. So let me set it as a today's date. Order ID, I don't want to set it. I want to generate that from the custom generator. Now here bean dot save of entity, bean dot save of entity. Now I am calling that save method. Now let me get this saved entity. I want to print this on the console. System.out.println, which is saved entity. System.out.println, which is saved entity. And nothing I'm doing, just I'm testing is my save method is working as expected or not with the custom generator. Just I'm checking that logic. Fine. Any confusion over here? Anybody has any confusion here? No. Let me do one small change in the entity. Date right, I will specify this as @temporal date type. Otherwise it will use timestamp to set the date. Now I am using temporal, which is give mmddy by date format by using temporal. Fine. No. Remove this sequence that I created here. I'm keeping this. Now run this program and see the details. Go to main class. Run as boot app. Launching this application. Console. As the table is not available, it created the table into the database because we enabled auto DDL. With that auto DDL, table also created in the database. Order details. Table got created. Inserted the record into table with order ID as OD1. That OD1 is generated from our custom generator. Right now, go to database, select star from order details. Oh, not this one. What is our table? Order details. No, we are able to insert that record OD1 Miller, place date is today's date. Now let me insert one more record and check the behavior. Orlan. Inserting. This time table will not be created because table already available in the database. So it is just going to insert that record into the table with order ID as OD2. Second number it has read from the sequence. Now check in the database. Order ID details OD2 is generated. Now it is a alphanumeric characters. So that is the reason we have taken varchar as a data type. If I take a number, we can't do this value insertion. So we need to make sure based on the type of the data you are going to store for the column, based on that you need to decide data type. So as it is a alphanumeric column, in my entity variable type I have taken as a string which represents as a varchar data type in the database table. Now if I insert one more record, then it will be inserted as a OD3. Charles. Yes, inserted the record with ID as a OD3. Order ID is equal to OD3. Now in the DB also we can verify the record Charles record inserted with OD3 as a primary key column value. So this is how we are going to implement custom generators in our application according to the project requirement. I hope all of you clear with this, how to create a custom generator. So this is the logic we are writing for custom generator and how to map the custom generator in the entity class. So this is how we are mapping custom generator to entity class by using generic generator and at generated value annotations we are using. Alright guys, thank you.
This conference is no longer being recorded.